Hey everyone, welcome to Unit 2, Systems of Equations. Lesson 1 is talking about solving systems by graphing. So let's talk about what systems of equations are. Systems of equations are two or more equations that share the same variables. And I'm going to show you some examples of those as we go on. Let's talk about what kind of solutions we can get with these. Okay? Because we're talking about two or more equations with the same variables, a lot of the times we use x's and y's. And with two variables like this, we usually get linear results. So the types of solutions that we would get would be either one solution written as xy coordinate, which I'll show you what that looks like down here. Second option would be no solutions, and the third option would be that would have infinite many solutions. So looking at each of those types, as I said, because there's two variables with two equations, we could rewrite them in y equals mx plus b form, right? Y-intercept form, and we can graph them as lines. And where those lines intersect would be the solution set, right? So here we see these two lines are intersecting at 2, -1. Those would be the only places where these two lines have in common for those variables. Anywhere else would not work. Second option, we have no solutions. Notice how these two lines are parallel. They have the same slope. They're never going to intersect with each other. So if an intersection is a type of solution, and here we see that they never intersect, obviously there would be no solutions. And the final option would be, well, what if they're constantly intersecting? What if they're the same line? They're just laying on top of each other. Well, we have infinitely many intersections along these two lines, which would mean that we'd have infinitely many solutions. Basically, when we see the same line show up, right? It's an overlap. So those are the types of solutions. Let's look at an example. This lesson's really good, by the way, because it's giving you a very good visual of what's going on. And when we start talking in pre-calculus about systems of three equations, it would look like this, but three-dimensionally. We'd see where planes are intersecting. But we're going to stick with two dimensions for right now, two variables. And here's our first example. You're going to need some graphing paper. So if you don't have that yet, you might want to grab some. I have here, this is a 7 by 7 plane, so you might want to get 10 by 10s or so, would work best for this lesson. Alright, so what we're going to do first is we're going to put each of these into y equals mx plus b form. And I'm going to do these in two different colors. We'll do the first one in pink. Right, so I'm going to want to isolate y by subtracting 6x on both sides. I'm going to rewrite this down here. Right, I have 3y equals, I like putting my x first, so -6x minus 6. And then last, I'm going to divide everything by 3. Notice, by the way, I'm doing this individually. This is an easier way for me to see exactly what my slope is and my y-intercept if I do it individually. All right, so I got y. This will reduce to -2x. I can put that over 1 if I wanted to. And down here, I also have -2. All right, so now I have it in slope-intercept form. I'm going to plot and then graph the rest of this. Down 2 over 1, down 2 over 1. And as backwards, I'd be going up and backwards, up, backwards, right? Continuing with that slope. Now you notice that I made these points nice and bold. Okay, when I go to draw in my line, if you have a straight edge, it's easier. If you're doing it by hand, do it as straight as you can. All right. Alright, now the reason why these are nice and bold is because I don't know where, but I'm hoping somewhere along this line it's going to intersect for a solution. So I want to see, you know, nice and big where these points are, because hopefully it will cross right along on one of these for me. That's my hopes. So we have to change this into point slope form as well. So let's add 2x to both sides here. Again, I'm going to rewrite. I have 3y equals, we'll put my x first, and then we'll divide each term. So let's see, I have y equals, this won't reduce, 2/3 x, and 18 divided by 3 is 6. So now I'm going to graph this, and hopefully they'll intersect for us. Right, here's my y-intercept, my slope of up 2 over 3. Well, not going to go too much further that way. Down 2 and backwards 3, down 2, backwards 3. Good, I see where it's crossing. I'm going to finish drawing in this line. Okay. And where they intersect is our solution. Oops. So, this point right here, that coordinate is -3, 4. That's our solution. What that means is, if I were to take this -3 and plug it into each of these x's, and I plug this 4 into each of these y's, we'll get -6 and 18 respectively for these particular equations. And that's the only xy combination that will actually yield true results. If we tried any other coordinate, something wouldn't work, right? Something would be messed up. Okay, so we're going to look at a couple more examples. Got 3 more to show you, and then 3 for you to try on your own. Okay, so first we're going to do another example to see what solution sets look like. Okay, if you want to take another second to write these down, I have another 6x6 coordinate plane. Again, we're going to want to isolate y. So I'm going to add 2x to both sides. I'm going to rewrite over here for y equals, I like to put my x first, then my constant. Again, we'll divide by 4. This will reduce to 1/2, and this will reduce to -1. So now I can graph. Here's my y-intercept, my slope of up 1 over 2, or down 1 backwards 2. Okay, and then we'll draw that line in. All right. Now we'll do the same thing with our second equation. I'm doing it in green this time. We're going to add x to both sides of the equation here. I'm going to just rewrite. I have y equals, I'll put my x in front. I can also put a little 1 over 1 here, right? That shows me what my slope is, because it's assumed to be a 1. So here we go. Here's my y-intercept, my slope of up 1 over 1, up 1 over 1, up 1 over 1. Right, we just keep on repeating that. I see where it crosses. I know what it looks like on the other side. We'll draw that in now. Okay, so there's my second line. And where they intersect is what we're looking for. That's the solution to this problem. That particular intersection is at 4, 1. So again, just reiterating, the 4, if I were to plug it into each of these original equations, and the 1, it would give us these solutions, right? Nothing else on this plane would work except for that particular coordinate. Okay, so now I'm going to show you some of the other solution types, right? I said that there were solution sets, but then there's also no solutions and infinitely many. So let's take a look at those. We're going to do it in the pink and green again, just like before. Okay, still putting this in the slope-intercept form, so we're going to want to subtract 2x from both sides. So 6y equals -2x plus 6. Then we'll divide everything by 6. Y equals, let's see, this reduces to -1/3 x plus 1. So we can graph that. Here's our y-intercept. Our slope is -1/3. All right. Just drawing our line right there. Now we're going to do the same thing with our second equation, right? I have to subtract x from both sides. So let's see, 3y equals -x minus 6. Then we'll divide by 3. And we get y equals, let's see, there's technically a 1 there, -1/3 x. -6 divided by 3 is -2. So my y-intercept down here at -2, slope of down 1 over 3. Right, and the same on the other side. Now, I already know this about my slopes. I remember from geometry doing a little bit of parallel and perpendicular. I see that these have the same slopes, right? -1/3, -1/3. And they have different y-intercepts, right? That makes these lines parallel. We said that parallel lines have no solutions, right? There's nowhere that we can pick that will give us these solutions. It's not going to happen. They don't intersect. Okay, so that's what they look like visually, parallel lines. You can see -1/3, I'm sorry, -1/3, -1/3. Those are the same slopes, different intercepts. Let's check out what happens with infinite solutions. Okay, again, we're going to solve for y. So I'm going to, add 4x to start. So let's see, 3y equals 4x plus 9. Divide by 3. Y equals 4/3 x plus 3. Alright, here we go. Well, I can't really graph the 4/3. It's too much over here, but I can go down 4, backwards 3. I can show at least a couple of points, right? So there's our 4/3. Now let's graph the other one, right? I'm going to subtract 8x. So let's see, I have -6y equals -8x minus 18 divided by -6. Hey, look at this. Double negatives cancel out. 8 and 6 will reduce to 4 over 3. And -18 divided by -6 is +3. So look at that. It's the same equation, right? Same y-intercept and slope. So here's my y-intercept. That gives me the next point according to my slope. And there you have it. The same exact line, same equation, same line. So how often are they intersecting? They're intersecting constantly, right? Infinite many number of times. So we would say here, you could abbreviate it with the infinity sign, or you could write the actual word. Infinite, probably going to spell this wrong. Spelling's not my best here, guys. Sorry if I spelled infinite wrong. Okay, but here you go. Here are 3 all on the same screen. Solution set where they intersect, no solutions where they are parallel, and then infinitely many where they're the same line. So I've got 3 for you to try out right here. I'm not telling you what the answers are or if all of them, the types will show up. Maybe some of them will, some of them won't. I don't know. I don't remember. I wrote this a while ago. So try them out. Here's one right now. Try these 2 out. If you want, pause the video. I'll go over these 2, and there's one more after. So do these 2, one more. Alright, let's see. By the way, you did not have to do these in multiple colors on your own. I'm just doing it on the screen so we can see what's going on. Right, I want to isolate y, so we'll add x to both sides. So let's see, that gives us 2y equals x plus 4. Then we'll divide by 2. That gives us y equals, let's see, there's a 1 up here, so 1/2 x. 4 divided by 2 is 2. So here's our first line. The slope of 1/2. Okay, so you want to check first of all, did you have the correct equation? Second of all, did you graph it in the right place? We'll check our second one. I'm going to subtract 3x from both sides. So let's see, -2y equals -3x plus 4. We'll divide by -2. Double negatives, those will eliminate. So 3/2 x minus 2. So here's my -2. I want to go up 3 and over 2, up 3 over 2, or down 3 and backwards. I already see where it intersects. That's good. That intersection is right here at 1, 2, 3, 4, 4. Hopefully you got 4, 4 for that one. Okay, again, check your equations. Are these the equations you got? And then check, did you graph them properly? Sometimes you get the right equations and just graph wrong by accident. Maybe you lost a negative sign somewhere. It happens. Right? Here's our second one. We want to isolate y, so let's subtract 3x from both sides. That gives us y equals negative 3x. I'm going to put the plus 0. I'm also going to put an over 1. Right? That's my y-intercept. I can show that there. No big deal. And I know I got to go down 3 and over 1. Or I could go up 3 and backwards. But here is our line. Okay. Then we'll do the same thing with the second one. We'll subtract 6x from both sides. So 2y equals negative 6x minus 8. Divide everything by 2. Let's see, that's negative 3 over 1x minus 4. So 1, 2, 3, 4. Slope is minus 3 over 1. Or we could go backwards, 3 up 1. Hey, wait a second. These are the same slopes, right? So not only can I see it in the equations themselves, but I can see it visually. These lines are parallel, right? So there are no solutions. Okay, almost done. Got one more. Just wouldn't be, it wasn't on the screen, so that's the last one. Pause the video and resume when you're ready to check your answers. Alright, let's check it out. You should have started by subtracting 3x, which would have been 4y equals negative 3x plus 4. Then divide each term by 4. Y equals negative 3 over 4x plus 1. So here's our 1. It's negative, so 1, 2, 3, and then over 4. 3, 1, 2, 3, 4. I kind of went off my paper there. Or we could go up and backwards. And one final line to graph. Let's subtract x. So negative 2y equals negative x plus 8 divided by negative 2. Let's see. 1/2 x minus 4. So here's minus 4. Up 1 over 2. Hey, it looks like we have a solution for this one. Our solution here, 1, 2, 3, 4, and negative 2. Okay, not really that bad, right? If you can graph lines, you can get these problems, right? Because all you're doing is graphing two lines and then seeing if they intersect, where they intersect, and if they don't, then you don't have any solutions. Pretty straightforward. Hopefully this visual way of doing this is helpful for you, because we're going to start looking at doing these algebraically, and hopefully you understand what's going on when we see what our solutions are in the future. Any questions you might have, either leave them in the comments, bring them back to class would be the best place to bring them. See you later.